How did different people extend the table? Anybody want to put their values up there? Yeah.
Well, I wanted to keep going with the 3 first.
Okay, Mary, would you write?
Sure.
And we'll just record, so we could
So I
sort of
kinda-
put a line through that 4
Yeah, I
there.
kind of ignored the 4. I wanted to go to that
For now.
next. So I just did 3. I just kept going with the pattern. 3 and then 3 and then 10. And then 3 and then 4 and then 13. And I'll be interested to talk about how we get the kid. I mean, my kids will say, "Oh, it's just going up by 3 every time."
It's
That's
going, yes.
That's what they're gonna
Mhm.
say. But then to make the connection between the two, well, the number of layers is constant. The number of cuts is varying, and the number of pieces of string is varying, and how do you go from that to, I mean, I know the equation of a line, so I immediately thought of that.
Oh.
But, I mean, when I was trying to come up with the
And
equation, but
some
I'm
kids
trying-
wouldn't even recognize it necessarily as a linear relationship in this format, would they?
Well, yeah, they might not.
They-
That's
yeah,
true.
yes, I mean, you did
Because you're
that.
seeing it, yeah, with the three values, because generally we've only done 2.
Uh-huh.
Right.
2 in the
Mhm.
table. So, yeah, I'm curious to see how we come up
But you
with.
raised, God bless you, you raised that issue of, how do we make the leap
Yeah.
from filling in
Mhm.
values in the table to then writing or recognizing a general formula?
Or
And-
even if you see the pattern,
Yeah.
just because you see the pattern doesn't mean you can
Yes.
write an equation. It's like, I
Yes.
could tell you how to get there, but I'm not sure how to generalize it for no matter what the number of cuts are and the number of strings
It's
are.
huge. Guys, it's huge. And if I had the answer to the question, I wouldn't be here into that one. But I can tell you this, much. We want to validate, certainly, the kid who says, well, it's going up by 3
Right.
each time. That is a
Right.
valid and good observation. And what we're looking for them to do, just for your information, that's called scalar reasoning. We are looking for them to go across, to reason across. If as the number of cuts vary by 1, they're realizing that the number of pieces of string vary by 3, that's what we want them to see. That's sort of a covariation approach. Because this goes by 1, that goes by 3, you hear that proportional reasoning in it? Then to come up with the equation,
But I think that's, I mean, you can tie in science with this, you can, I mean, by this
You're
point,
good.
you would be doing independent, dependent, domain, range, all of these things that I think even before you would wanna have them look at that, I would say, let's talk about what's up there and show the change in X, the change in Y, talk about the change in Y over the change of X. What does the change of Y over the change of X mean? Oh wait, I think that's M, oh what's M, oh that's slope, oh, okay, well what's our initial value? I think there's so many things by our questioning.
Ways that this could go by our
that you
questioning.
can- Right,
Yes.
where you just first go.
Did everybody
well, when is
follow
our-
that remark about the change in Y's over the change in X's generating the slope? You
Well, and
know.
even just talking about, well, which one would be an X, which one would be an Y? Wait, are there 2 X's? Are there 2, what is this? What is an X? Oh, that's the independent, that's what we
Okay.
have control over. I mean, there's so many good conversations to
Yes.
have out of this.
Thank you, yes. What if you were dealing with a kid who hadn't learned the MX plus B form of a line? And so when he or she was asked to try and think how to write, and I think maybe that's partly what you were asking, how to come up with a general equation for this, a general equation model. How do we encourage that leap? And I've been saying that, do not think I'm discrediting what you said, because I'm not. It's a gold mine here. We have
Yeah.
a gold mine of directions that we can go with this. And I am delighted to hear you notice that. Did you have a thought?
Well, when we used to do things like this in our algebra program, even though we only did it with 2s, the 3, we still had them always write it in words. Well, can you tell me in words what's going on? So then we took those words and put them into an equation, and then we started talking about variables, what could you use to represent it. So we always start off with, can you describe what's going on? Can you put it into an equation format? And then we got into what does it look like, and that's a way of introducing your Y equals MX plus B.
I can't tell you how important that is, to take the time to let the oral language, or in some cases written language, become the bridge from the real world context to the formal equation, what sort of explanations would we be looking for from kids if we wanted to do this? What would we want, what questions could we pose? What would we want to?
Well, you could do that number game too, you were talking about.
Okay.
The input, output.
Yes.
But, yeah, when I was looking at it, it kind of threw me off, well, I mean, I came up with the equation, but three idea gave, well, you could say, where's the three, where do you see that three coming up somewhere in the problem?
Yeah.
Where do you notice that three, anywhere?
Yes.
And maybe somebody would say the number of layers.
Yes, yes.
I wonder if that always works. Let's try another example.
Mhm.
Let's try
With
4
3 layers.
Well, let's try 4 layers even.
And then see what happens.
And see what happens to the number of pieces of string. Does that happen?
So what I hear you saying is, whatever numerically we're doing in the table, if we can relate it to the physical context of the string situation, we can help it have meaning for the kids.
Oh, yeah.
Yeah.
Well, and I think anytime, I mean, those are 3 steps to metacognition. You think about it, you talk about it, then you write about it.
Wonderful.
And that's how it's gonna be stored into that long-term memory for them to have that as an experience.
You're also teaching them to kind of disregard something
Mm-hmm.
Oh.
that may not
Yes.
be as helpful to them at this point, but they can work it back in later.
Maybe.
So if
What
they
do you
saw
have
the
in mind
pattern
with
with,
that?
well, like Patty said, with the number of layers being 3, and she says, okay, well, this 4 might be throwing me off, let me ignore this.
Let me
And
control
continue-
for that for a
Exactly.
minute,
Continue
yes.
on the 3 and like, oh, I really see what's going on, now let's choose 4 or 5, or, and if you get to your words, you could say, well, what happens if you have 7 layers, could you tell me without drawing your picture, and then verify with the picture, and it
Wonderful.
helps you get to your equation as well.
Yes, wonderful. We at some point, we do want to, I noticed the language on Max's tape this morning, he talked about contextualizing and decontextualizing. At some point, we do want to step away from the context to focus on the math model that we're using, decontextualize. And we may come back to that context when we want to verify or for ourselves that we have found a correct answer. What else can we ask ourselves about this? I don't know that I've gone through all our questions with this.
What about if you were still having an issue with getting to that equation, what if you just put an equation up on the board and said, this is the answer, now tell me how this got to there? And just talk about the process. Why does the answer key always have to be so secretive?
You guys don't, you don't need us. We need you. If I heard you correctly, I'm thinking, what if I just filled in a value here and said, can you tell me, let's say we're working within the 3 domain, the domain of 3. And as a teacher, I'm on the spot here, okay, I wanna do this, and so I'm thinking, I wanna pick a number on down this list somewhere that, and I want it to work. So what am I gonna have to pick? I'm thinking a multiple of 3 plus 1. See, that's where my brain is, and that's not where the kids are necessarily.
No.
But give me a multiple of 3, 30 plus 1. Suppose I put 31 in here. And I said, I'm gonna tell you that it has 3 layers. You tell me how many cuts I would have to make to produce that.
You need to do a bigger number, because they'll sit there and.
Really large, 'cause
Oh,
they'll
do
just
it in
keep doing
reverse.
it.
Some kids will just bust through every stage to get there, and so we might have to go to a much bigger number. Am I hitting on what your comment? Yeah.
Oh, this is definitely I thought of it this way, and I thought of it as just giving them what,
If you
max-
actually gave them the equation, like,
Yeah.
suppose they're so stuck
Yes.
that, I hear what you're saying, that
Yeah.
you give them the equation and work backwards from
Uh-huh.
there.
And to, like, where did this, how is this
How do you
the
think
answer?
we got this, now, where do you think this came from, where with all of this is this supported?
How is the equation and the table related?
Yes,
Make
and
it
the
right.
table and the
Yeah.
real world situation, how do they all relate, and then I can see how that equation might have been involved. This is beautiful, thank you
Well, I
so
mean, maybe
much.
they even need it as a graph.
Do it as a
of some-
graph, yeah.
Right.
And you'd see there that it's linear.
If they're more
Correct.
visual, yeah.
You know, for years,
Yeah.
yes, yes,
Yeah.
it would have to be
Oh,
discrete, I
this
guess.
would be
Oh,
an
yes.
awesome one,
Number of
that's such a
cuts.
tough idea for them. I'm writing that
They're
down,
so good.
discreters.
For a number of years, we were worried about giving the answer to kids, giving away the answer. And I have an opinion about that I'm gonna share with you. I think we do want to be careful about giving away the answer to something too quickly. But if we have students who are truly engaged, and, you know, I'm looking at you all, you model students, you're truly engaged with this, and we can tell among our own students who's engaged and who isn't, can't we?
Oh,
Can't we?
yes.
It's not hard. If you have a student who's truly engaged
Oh, yeah.
and truly struggling, I think of what you've described, maybe giving the equation and saying, can you work backwards and see how this relates to that and that to that? I think of that as scaffolding.
Yeah, or even, and I
form of
mean, it's not
scaffolding.
even just can you, but okay, now in your groups, I mean, go back to Kagan strategies. In your groups, talk about how those are related, and then I'm pulling popsicle sticks, and everybody better have an answer. You know, and
Yes.
in formulating that discussion, I think that's so critical, is for them to talk.
It is, and that's what the Common Core
Right,
standards
'cause,
practices are
they
asking
tune us
from
out.
us.
They don't wanna listen to us, but they'll listen from each other.
Yeah, and they want to do, let's
Oh, yeah.
face it, they want to do. Anybody want to add more to this? Anything else to this? Let's leave this for now. I think we've covered enough. And we'll go to an example for the high school. Does that sound okay? No, I think we've covered the questions.
I really appreciate what you said, Tammy. I never thought to do it like that. I always felt like I could get maybe 2 kids to come up with the equation at the end. We do all of this, fill out the table.
Yeah.
And I'm just
Yes.
like, come on,
Yes.
you can do it, you can do it. And 2, maybe the brightest kid in the
Two
class
do
figured it out.
The same 2 every time.
Yeah.
Or
And-
even, like, I helped a lot of the kids this year early on with the slope when we had, you know, we did like the carrots out, and I'm like, wow, what is the change in Y? Now what is the change in X? And all of a sudden, there's some light bulbs going off, like,
Uh-huh.
oh, I remember that.
That's wonderful.
But I like the idea of giving the
groups.
answer.
Oh, the answer.
Giving the answer
Yes.
for those, I'm thinking of a kid in particular, it wouldn't matter how long I waited for her, she would
It's
just.
not gonna
Right.
happen.
And
They
but
just
even
don't, but
the-
they could fill that table out for hours.
Yeah, yeah.
Yeah.
But just won't see the equation,
Yeah.
and just, but if you show it backward, just for some people.
Just to give them something to,
Yeah.
I mean.
And I mean, how many times have we gone to the back of the
That's
book?
what that's what
and
the
then-
calcs, I give my calc students the answer key, so
Yeah,
they can
here,
check
so-
their answers,
Yes.
and they tell me, all right, I know what the answer is, I start reasoning how to do it, it's a good.
Right, yeah.
Just didn't think to do it with the lower level kids.
Do you know, forgive me, this is a Piagetian thing, when we do that reversibility of thought.
Yeah.
And when we're willing to work backwards to something, is an indication of a level of reasoning that's a little bit more advanced, and so there's nothing wrong with it. Where we have a problem is when we jump to that sort of thing too quickly, or our kids haven't truly engaged. Maybe they've gotten used to it. I know if I wait her out, she'll.
Yeah, oh, yeah.
She'll break
Yeah.
down.
Yeah.
Yeah,
Yes,
I do.
yes.
Yeah. Well, you only
Well,
have
just give
50
her some
minutes,
But it's
so.
important to use it as, if you're going to solve any problem, you first have to understand the problem, talk about what you understand and what you still need
Oh,
to
yeah.
know to create your
Yeah.
plan. And you always have to have a solving part and a checking part. So if, to solve this problem, you needed to see the answer first and work backwards, then you're also gonna have to check that.
Okay,
And
I
work the
love
other
it,
way.
I love it.
So then you're getting both sides
Uh-huh.
to it. And after that, you need to write your interpretation in words to give that example of what this truly means in the mathematics context and also in the real life application context.
That's wonderful.
I just want to add one thing too. I was just thinking with the linear stuff, I really like, the one thing about the PARP is starting off with functions where they're not seeing linear all the time.
Yeah.
Yes.
Yeah.
Because then they just assume everything's linear.
Exactly.
So-
We just
We
had this
had this
conversation.
conversation.
Do
We
we
are
have some
teaching.
problems for you?
Okay, let's go.
Yeah, let's go.
The next thing we're gonna have you do is on, the next page, I think, of this handout, and it is an example from high school. If you'll allow me, I'll just read through it with you. I want you, maybe we can do this in our heads. I want you to, select a number in your head.
I'm gonna write.
Got it? Yeah, go ahead.
I need a
I was gonna say,
modification.
if you're like me, I'll forget the number before I do the
I'm
second
gonna start with a low one.
Yes, start with any number you want, but when you hear the second question, you may change your number. The second statement says, next, oh, I want you to square the number. So you've written the number down,
Got it.
then write the square of the number down. And then, I want you to identify 2 numbers, one of which is 1 less than your original number, and the second of which is 1 more than your original number. Got it?
Whole number or,
I'm thinking whole number.
okay.
Be easier. if you
I'm
just
thinking you probably could do this with, decimal numbers or factual numbers. Then I want you to just find the product of those two numbers, the one that's one more and the one that's one less. How does this product compare to the original squared number? Anybody there yet? Do you need a minute? I'm making you do this by hand. Bring your calculators.
This is great, this is,
No, this is
now I
good.
wanna know if it always works no matter what the two numbers are.
Well, that's the question. That is the question, does it, okay.
it just
And when we
always-
say, does it always work, what is it that we're thinking doesn't always work? Working away, working away.
Wow. It does with like, for 1 to 10, when you start being the product of the
You
two
put zero
board, the
down.
two outers
Yes.
is one less than the square of the number you chose.
Zero.
You said that so beautifully, Mary. The product of the two outers appears to be one less than
No,
the
it
square of
works.
the original number.
I mean, it works for,
Can you say
two-
that slower?
Okay.
It's so beautiful
Oh,
the
the
way she
original
I know,
number, sorry.
isn't she
yeah,
wonderful?
like the product
Got it,
linear.
got
it. I
The
did.
outers are 2 and 4, so 2 times 4 is 8, which is 1 less than 3 squared, which is 9. Pick 2 more, pick 4. So now look at 3 times 5 is 15, but 4 squared is 16.
Oh, I didn't do the 4 squared, cause I did
Okay.
the 2 squared originally.
Oh, well, and then you'd have 1 and 3. So
Right.
2 squared is 4, 1
Right.
times 3 is 3, which is 1 less than 4.
Got it.
Yeah,
Got
and,
it.
well, at least
Wow.
up to 10, I'm guessing it goes on.
How we doing?
Good hypothesis, we're good, science, we go.
Is it always true? Oh, we have one person who's pretty sure it's always true. And did you work out a little proof of that?
Using variables, yeah.
Did you?
Oh, how
Okay.
cool.
Well,
Never thought of that.
I mean, have we explored our initial cases enough to go on to this next level question, is it always true? I mean, did anybody come up with a situation where they picked a number, they squared it, then when they took the two outer numbers product, it wasn't one less?
Out of the numbers that I can do in my head, no.
Okay, yeah, this would be a good one for having a calculator. And Jenny has told us that she's pretty sure this is always true, that in fact, she's real confident that this is always true. And I'm having a teaching dilemma at this moment, because I want to say to little Jenny, would you put your proof up for us to all see? I think I'm going to ask her to do that. I'm going to ask you to do that. Would you do that?
Sure.
But of course, I'm going to ask you to explain
Okay.
the reason you did everything you did.
Okay.
Okay.
Why don't we have someone else explain why she did everything?
Oh, that'd be beautiful. Would you be comfortable with that?
That's fine.
Okay.
And then
Do you want me to write
That-
it on the
that-
board or on the
that-
smartboard?
Either.
Because I think Mary
think-
wants to share.
No, I didn't even think of it that way. I'm
I
so.
know. Or we can ask
Sorry.
Jenny a question.
Can we go to a?
No, I get it.
Just
Well,
a
you
white
can write on,
page?
it's okay, I could write on the whiteboard, or,
Okay.
Yeah.
there's not really a lot of space to write on that
Yeah.
slide unless you
And I
have
don't think I
one
have
for
a
me.
blank.
Yeah. You wanna slow things down, is it too fast to say that you, the numbers you pick, positive
Yeah.
or negative?
Oh.
To go negative case, did you do
Oh, you're so
integer or
mean. I
Did you
actually
hear
thought of
this?
that.
Did you hear this? Share this. Want to
Well,
slow
it's-
somebody
If you
down?
wanna slow somebody down, or if they're positive and you just kinda wanna make them extend that more, ask them, did you use a positive or
Yeah,
negative
it didn't
number?
come up,
Do
did
the,
it?
the other. Did you use
Oh.
an integer or a fraction? Try that. And then they have their
Now,
different cases.
I have to be honest, I've never tried this with
Oh, just say
negative
yes.
numbers. And I've never tried it with a fraction, so
Oh, I see. It's
I'm
open
now
to
wanting,
tutorial.
I'm motivated, I
I
wanna
don't
do
want
this.
Tutorial, I just want a new page.
Very cool.
Alright.
Oops.
Every day, we don't care. I don't know.
I always say our smart boards are not as smart as your smart boards, because ours aren't as
My
well
smart board's
maintained
smarter
as
than
your
yours.
smart boards.
This is amazing.
Oh, wait, we gotta slow down right
Okay.
now.
I was gonna know if you wanted me
Somebody
to write
else is,
everything up.
we're gonna have somebody else explain?
Well, after she's done.
Oh, you want her to write it all
Oh,
out?
no, you should do it step by
Oh, you
step,
could
then
do it
it'll make
step by-
sense.
Okay, chime in, Mary.
Whoa, look at